Hey there, everybody, and welcome to the Daily Space Weather. Another exciting edition here featuring all kinds of solar activity as we get closer and closer over the next, I'll say 10 months, to solar maximum. What you're looking at here is the past 24 hours from the Solar Dynamics Observatory in the spectacular 171 angstroms wavelength. It's a 24-hour video. The 171 angstroms wavelength is great at showing the lower corona. So we'll be showing that, the flare, sunspots, coronal holes, and lots more on today's Daily Space Weather. And thanks for tuning into the Smash News Network, least busted name in news. The largest flare of the past 24 hours came from this sunspot down here. It was a large M-class flare. Again, we'll talk about that in a little bit more detail and show more detailed imagery of it as well. First, let's go around the horn. We do have a couple of new sunspots that have not gotten names yet. You can expect at least 2 new named sunspot groups today. There is one of them rising up over the northeastern limb. Here's the full northern hemisphere. These are all 24-hour videos, by the way. And here is the western limb. A couple active regions there setting, some of which are indeed sunspot groups. Here's a close-up of the northwestern limb. And thanks for leaving comments, Mr. Bordages. Here's the southwestern limb. How about just the southern hemisphere? You may see a huge filament there, just to the east of the Earth scale. We'll be talking more about that crown prominence, which, by the way, you can expect to see more and more crown prominences as we get closer and closer to solar maximum. There's a great close-up of that huge plasma filament there. And we're going to talk sunspots and magnetic fields and earthquakes and volcanoes and lots more. But before we do that, please take a moment to visit our links. You may find some affiliate links. You may notice that there is a paid sponsor/affiliate for this video. The paid promotion is for partially our Amazon shop, so you can find our shop there at amazon.com/shop/smashomash. Today's featured product is our fantastic bamboo cutting board. Yeah, it's got a juice groove around the edge. $27.99. You can find that right conveniently on the list. Today's featured product from the Hemp Lucid shop are CBD tinctures. So the main difference here is water-soluble versus oil-based CBD tinctures. The difference is that water-based CBD tinctures will affect you more quickly. Oil-based CBD tinctures will have a longer duration. So that's one of the major differences there you'll have with the Hemp Lucid CBD products. If you do pick some up, make sure you enter the promo code SMASHOMASH. So while you're shopping at hemplucid.com, just simply enter the promo code SMASHOMASH. That'll save you 10% on your order. There is also a link below this video and on our homepage at smashomash.com. And welcome to the Neo Renaissance. Today's featured product is one of our latest, the Croissant Earth Society. When will you stop believing NASA's lies? Don't you know that NASA was formed by actual Nazis under Operation Paperclip? What, are you living in the darkness? What, don't you know that NASA controls the weather and that Earth is actually croissant-shaped? Yeah, they took a huge bite out of the Earth back in the 1950s, changing its orbit and driving it away from the sun. We've got an artificial sun now and a croissant-shaped planet. So if you weren't aware of that, the sun simulator and all that sort of stuff, stop believing NASA's lies, will you? Why not join the Croissant Earth Society with our handsome, high-resolution graphic design there, featuring a real image of the planet on which you live. It's shaped like a breakfast pastry, the French breakfast pastry, known as the croissant. Not an oblate spheroid. What are you, some kind of a psycho? And we've had a timeout. All right, there we go. That usually does not happen. So let's getting back to solar activity here. there is the sunspot scenario via the SDO intensitygram, and that is a lot of sunspots. Like we've been saying for a few days here, we're pushing the sunspot number of 200. So, and by the way, we still aren't at solar maximum. So there's that. We'll also show the magnetic fields. Like the last series of images, this is actually yesterday plus today. So that's June 22nd, the entire day, and June 23rd, to the point where we made this video. So I think we may have actually like 3 new named sunspot groups. Because I think, yeah, there's one rapidly formed down here. Look at how high of a latitude that is, how far from the equator that sunspot group is. That's a beta gamma class sunspot group also. So we'll have 3 groups at least to get names today. I'll make it 4. Yeah, 3 or 4. Several new named sunspot groups to get named today. So it's an ongoing solar uptick, and you can expect it to continue, like I said earlier, for like an additional 10 months, which means you can expect another nearly 2 years of activity around these levels from the sun. As far as volcanic activity on Earth goes, let's see what's happening. We've got a new volcano on the list here. First, Mount Ibu is erupting. It's producing an 8,000-foot ash plume over Halmahera, Indonesia. Semeru is producing a 15,000-foot ash plume over East Java, Indonesia. It's a flight level 150. 8,000-foot ash plume over Dacono as it explodes. It's a flight level 080. Nevado del Ruiz in Colombia exploding, flight level 200. That's a 20,000-foot ash plume. Please do not pole vault the caldera. Sabancaya exploding in Peru, flight level 210, 21,000-foot ash plume, and a similarly sized ash plume over Ubinas in Peru as it explodes. It's a 21,000-foot ash plume, flight level 210. From 2 different volcanoes in Peru, and let's see what's going on seismically. So there is the 90-day bar graph. It's been pretty seismically calm over the past 24 hours. Not a lot of major earthquakes here. No major earthquakes, period. Only a few over a 5 magnitude. It's quite quiet. A low number of quakes, and no large quakes. There's plenty of nonsense on the internet about quakes. However, it must be a slow news day, which will cause certain YouTube channels to talk about weather modification, another thing that they do not understand the physics of. Anyway, in the past 24 hours, might have only been 1 or 2 5+ magnitude quakes. There was a 5.1 at the Kermadec Islands. That was 1933 Universal Time. That 5.1 occurred close to the surface. Estimated depth only 10 kilometers. So yeah, only 2 quakes, both in the same region of the planet there. A 5.1 and a 5.0 at the Kermadec Islands. So that's all that's been shaken. And let's get back to space. It's a little more exciting. And of course, we talked about that filament and how we'd be coming back to it. Well, here it is. Here's the filament once again. This is the 211 angstroms wavelength. We like to use this to show coronal holes, but also filaments have great contrast in this wavelength. You can also notice this area, there's like a dark cloud surrounding it, an indication of perhaps higher density, or at least a less amount of that species of ionized iron. That's a 24-hour video from SDO in 211 angstroms. Anyway, looking at some more stats here about space weather, the 10.7 centimeter radio flux now down to 173 solar flux units. And my microphone is full of space. Let's look at the 1-year graph. There you go, 173 solar flux units represented by this black line. And the sunspot number is still rising, folks. It made it up to 190. And like I said, we're going to go over 200 now, because having 3 new named sunspot groups, that'll be 18 more sunspots at the very least. That'll bring it to about 208. So yeah, that's the scenario. And let me just reiterate one more time. I don't care who's telling you that we've been at solar maximum since February or January. We aren't at solar maximum, and just keep watching the channel in the coming 2 years. You'll see why. We'll show great details about it. Anyway, here's the Space Weather Enthusiast dashboard and forecasting a little bit of geomagnetic unrest or mild geomagnetic storm conditions late tonight and into early tomorrow. So that it looks like NOAA might be watching our videos, finally. although we doubt it because of the pathetic number of views. So anyway, that's the Space Weather Enthusiast dashboard. And by the way, there is a second CME as well that we will talk about. And we've got limited data on that, so we're not sure if we'll be able to do a good forecast anyway. It's not been modeled yet by NOAA. So again, we are expecting a possible minor CME impact late tonight into early tomorrow. So that could produce some aurorae, probably nothing major. It's expected to be a glancing blow, if anything. I'll say it's got about a 33% chance of impact. So now, as far as the latest CME, NASA has not yet modeled it. So it's not even on this run yet. That's the Integrated Space Weather Analysis Center. If you want to go look for that yourself, it'll probably get modeled later today. Keep in mind, NASA has the most skin in the game, as astronauts are generally the most susceptible people in the world to space weather. Let's take a look at Earth's magnetic moment for the past 4 hours. This is our Geospace Magnetosphere movie. It depicts magnetohydrodynamic pressure, and it is a geomagnetically calm condition. Now, when you see the more pressure in the magneto-tail side, which would be on the right, that is the system attempting to reach static equilibrium after a weakening of the solar wind. Again, that's the last 4 hours of Earth's magnetic moment from space. Here are the last 4 hours of Earth's magnetic moment from the ground. The scale here is nanotesla. The units here are nanotesla. Magnetic flux density at the surface. Let us know if you see any quadrupoles or octopoles forming. I certainly don't, because keep in mind, that is what you would see if there was an actual pole flip happening. However, we don't see that. One of the many, 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 many indications that there is no magnetic pole reversal coming for planet Earth. Next, the KP index currently at 2. Yeah, KP2 is the current situation. Again, it's a geomagnetically calm condition. And let's look at the real-time solar wind. So here's the real-time solar wind situation. It's about 3.2 protons per cubic centimeter for the solar wind density. Solar wind speed here under 400 kilometers per second at 393 kilometers per second. The rest of that is unremarkable. So let's move on to the GOES magnetometers. There you go. Some little divergence and a convergence happening around midnight local time for the GOES 18. By the way, these N's and M's, these stand for midnight local time for the GOES 18. Here's noon local time for the GOES 16. That's what the N's and M's stand for. Those are geosynchronous near equatorial satellites. They orbit at about 23,500 miles of altitude. Next, we'll look at the heliospheric current sheet, as well as the coronal magnetism from this top view ecliptic plane field plot. And by the way, if you weren't aware, this is one of the most important space weather predictive features. So it's part of the National Solar Observatory. We call it the GONG-2 data. It is derived from 51 ground-based magnetometers, as well as magnetometers on stereo A, which is depicted right here, and stereo B, which is depicted right there, overlapping the Earth now, as Earth and stereo B are overtaking each other. Stereo A is in the process of catching up to and overtaking the Earth also. And like we said yesterday, the sector boundary crossing is not here yet. So if we bring up the latest image, Earth is still in a South Pole current sheet depicted here in red. That is the solar plasma's magnetism. You can see that North Pole current sheet coming. That may be here as early as tomorrow's video. So I suspect it's not going to show up until after tomorrow's video, but keep in mind the magnetic environment can change suddenly with basically no warning. Let's take a look at the line of sight field plot. And here you can see the B field rotating out there, and you can see that sector boundary crossing. If we bring up the last image here, you can see the North Pole current sheet is coming, and the South Pole current sheet is on its way out as it sets in the west. That brings us to coronal holes. They're super important. And keep in mind, folks, we had a comment yesterday about coronal hole magnetism, and I just wanted to note for people that this magnetism is in the sun's atmosphere, and when we show the sunspot imagery, these magnetic fields are on the sun's surface all the way down at the photosphere level. This is the photosphere, okay? This is the sun's atmosphere. That is 2 layers above that. It's like 1,000 kilometers higher altitude. In other words, the sun has different magnetic fields in its atmosphere than it has at the surface. So I just want people to be aware of that, because they are two completely, they're not completely separate systems, but the sun's atmosphere is very different in composition, magnetic field structure, etc., temperature, chemical components. That's very different than the photosphere. What you're looking at here are the magnetic fields of the corona, our line of sight coronal hole plot. So let's bring up some more imagery here. Here's 211 angstroms, the full disk 24-hour video. And we do have a trans-equatorial coronal hole. We can expect some high-speed wind from that in about 4 days. So that trans-equatorial coronal hole there, that is, that's a good question. That is South Pole, I think. Should be South Pole. Not even appearing there on the data yet. Not sure on that one. Could be South or North Pole. I think it's South Pole, though, because it seems to be on this side of the sector boundary crossing. So anyway, that's the past 24 hours in our favorite coronal hole wavelength, SDO 211 angstroms. Here's a zoom in. Allow me to zoom off screen. And let's move to sunspots. So here's this is also part of the Integrated Space Weather Analysis Center, the solar flare probability. We've got a very high likelihood of large solar flares in all kinds of different spots. I'm not even going to try to break down where the most likely places for large flares are. 3341 in the lower left has produced the largest flare of the past 24 hours. So statistically speaking, it's probably still the most likely, although we do have sunspots over here on the western limb. We've got new sunspots up in the northeast. I think there is a huge likelihood of a large flare up there in the northeast. So anyway, that's the situation. Very high likelihood of large flares to continue for a couple of years. And here's the past 24 hours zoomed in there from SDO. That's the SDO continuum. And again, let me just reiterate. Sunspots occur in the photosphere. In between the photosphere and the corona is another layer called the chromosphere, which is probably the least well understood of all. I would also note how much of a difference there is in latitude. So look at how far this sunspot appeared down here. I believe there's one way up here. We've got a very large difference in the latitudes here of these sunspots. And you can expect that to continue at these crazy levels and beyond for the coming years. Because, again, we aren't at solar maximum yet. I know there have been people saying on YouTube, people that have 10 times and 100 times the subscribers and views of us, but they're incorrect, or they're just outright lying about being at solar maximum. They're either misrepresenting or they are committing fraud. It's either a misrepresentation because they're mistaken, or it's fraud because they're lying to you. Either way, they're incorrect. Here's the past 3 days of energetic particles, and still no SEPs, no solar energetic particle events, even though we had a large flare just before midnight. So this large flare peak flux was around 2340 universal time, and it was about an M5 class flare. Let's zoom in by making this 1 day. It was an M4.9, so almost an M5 flare. And since then, things have been a lot more calm, but we are in a C-class background flux level. The background X-ray flux is about C1.34. And let's move to our solar flare wavelength. So here we've added 94 angstroms to the SDO continuum, highlighting those active regions. And here we've dropped the continuum and added 131. So now we've got 94 plus 131. Again, that M4.9 flare occurred down there in the southeastern limb. There was a coronal mass ejection associated with it, and based on the tiny amount of data that I have so far, I don't think it's earthly directed. Hopefully more data will come out today. Here's the full disk zoom in those same wavelengths. These are all 24-hour videos, by the way. Typically, our custom videos are 24 hours on the channel. It makes it easy to do daily space weather videos if you're showing all 24-hour videos. So occasionally we do show zoom-ins and stuff, and maybe we'll even do that later today. But first, let's talk some more stats. So again, there's the GOES X-ray flux. We usually show the 3-day. There's the 3-day chart. So we've had, let's see, it looks like 3 M-class flares in the past 3 days. And here's a brief look at what's going on overhead over Lehigh Valley, Pennsylvania. If you've got clear skies after dusk, you might see some great views up there of Mars as well as Venus. Also the moon. Venus, Mars, and the moon quite close together there on the ecliptic in your early evening skies just after sunset. Venus and Mars there. Next, your solar system forecast. This means something to astrologers for some reason. A lot of people believe the planets control solar activity or even their lives. So we just show the forecast and let the chips fall where they may. This is where things are today. And here's where all you heavenly bodies will be in a week. On June 30th. Continuing right along here, to remind you to press like, subscribe, share, etc. Is there a cage match going on the channel? Not today. Are we looking to feature a cage match in the future? Perhaps. Are we sick of the pathetic, putrid, and disgusting censorship on the internet? A little bit fed up with that. Anyway, if you haven't checked out our playlists, you can find playlists about stuff that has nothing to do with space weather on the channel. Thanks to all of our long-time subscribers, our new subscribers, etc. By the way, follow us on Instagram also if you weren't aware. You can find all kinds of fitness and lifestyle posts over there, and let's move to coronal mass ejections. So here are the 35 pathetic frames from yesterday, which doesn't show us very much. We usually have like 100 frames a day. And here are the unfortunate 5 frames from today. So that's not very helpful. We've also got a huge amount of missing data here from Soho, Lascaux, C2, and C3. That's why the runs are so short. And it's very unfortunate because right after the CME happened, here it's dissipating. You can see it moving off there to the lower left. See that? Unfortunately, that is not very helpful. I don't think it's earthly directed. It could have an earthly directed component, and if so, it will arrive sometime on the 26th. Yeah, late day on the 26th, probably. Maybe even midday on the 26th. There is a possibility of an Earth-directed component. I'll say it's 40% for that CME. Let's see if we can get any additional data here. There's stereo A, which I believe also has a huge data gap. And thanks for leaving a comment, Johnson. Johnson, do not watch space weather while you wax off. That would just be weird. Anyway, here's a 24-hour video from, this is a composite. It's got SDO 193 angstroms, as well as Soho, Lascaux, C2, and C3. And unfortunately, when you see the flare happen here, which is around 2340 universal time, right there, unfortunately, there's a bunch of missing data. So, again, it could have a small earthly directed component. I wouldn't expect anything besides a KP6 or so. If it does strike Earth, it will arrive sometime around like mid to late day on the 23rd. I mean the 26th. The 26th. So that would be Monday. Anyway, there's a closer up view of that. And of course, you can see some waves emanating from that flaring event there. Sort of a disk-wide feature happening there. you'll see like a reverberation all around the solar disk. That is a common thing to see, especially in the 193 angstroms wavelength. Some relativistic particles surely went flying around the time when that flare occurred. So keep in mind, folks, flares involve drastic reorientation of plasma features. In fact, flares may be caused by a drastic reorientation of plasma features. And let's continue on here because we've got to talk filaments yet. And the filament situation is pretty significant. Now keep in mind, filaments are the feature that often turns into a coronal mass ejection. And we've got still quite a few here, the most noteworthy of which, well, there are two noteworthy ones. This one down here could get a name. That's why we keep showing it. But this one up here already has a name. That's the Getty-Lee filament. So far, it remains intact. Once again, if you want to name filaments, why not join us over on Twitter? If you do social media, follow the hashtag #NameThatFilament. Keep in mind, this social media platform is completely broken intentionally, just like Alphabet, Apple, and Meta platforms. The Twitter platform is completely broken, barely functional. The hashtag system does not work. And boring, stale, already ultra-rich and famous celebrities with boring, stale ideas are promoted, while people like you don't have your posts seen. So that's the way the deboosting features work. And there's all kinds of ridiculous algorithms that make absolutely no sense. If you think free speech has been restored on the internet, you are delusional. Continuing on, again, follow the hashtag #NameThatFilament. I would recommend naming this one down here, because this one up here has already got a name. So the hashtag #NameThatFilament over on Twitter. And once again, there is that filament. I've got ideas, but I'm not going to. I'm thinking about naming that one Billy Sheehan. Yeah, since I picked a bassist. I know some pretty sweet bassists. I think my favorite is probably Les Claypool, or perhaps Bella Fleck. But anyway, if you want to name that filament, follow the hashtag #NameThatFilament on Twitter. You can find historic named filaments. By the way, the Tamitha Scove filament earlier this year provided a massive CME impact back in, I think, March or February. A great CME impact. Anyway, there's the Southern Hemisphere. This is 304 plus 193 angstroms, by the way, because it's great at showing the contrast of filaments. It's ionized iron plus helium. Also a great view of that flare. And there it goes once again. Here's the equatorial view. Again, not as many filaments as we had about 10 days ago, but still quite significant. Keep in mind they can build rather quickly, and they can be a little bit hard to see. There's a great view of the Getty-Lee filament there up in the upper left. It's that one that's shaped like a bass clef. Very plain to see there, that backwards S-shaped filament named for beloved Rush bassist Getty-Lee. This filament up here has settled down a bit, perhaps collapsing or perhaps ejecting on the far side of the closest star. Anyway, we're right back to where we started, and let's get to our bonus features here. Oh, and by the way, our forum is a bonus feature. If you haven't seen that, smashamash.com/forum. We created a massive web ring for people like you, and one of our forum threads is memes. So if you haven't seen our memes forum thread, there is a most recent meme billing the coming cage fight. Cage match! Who? Two overrated, overpaid man children. What? A pathetic cage match. When? Probably never. Where? Vegas. Why? An idiotic publicity stunt. How? They're billionaires and free speech destroying twats. Cage match coming. Everything you can shadow ban, I can shadow ban better. I can shadow ban everything better than you. No, you can't. Yes, I can. No, you can't. Yes, I can. That's what the argument is. The argument is who is able to shadow ban and make sure that your posts and tweets are not seen. Who's better at it? Let us know in the comments. Is Elon better at shadow banning you, or is Mark better? Or is Sundar Pichai the world leader in shadow bans? Just kidding, folks. Maybe the winner will square off versus Sundar Pichai. And then maybe that hack from Apple will clean up whoever's left. Here's the past couple of hours from the GOES 18 SUVi. And we're seeing a lot of plasma instability happening right up here. So if we're going to see a CME, I wouldn't be surprised to see one come from this area, as we're seeing a bunch of material moving around up there. Also, you can see some stuff happening over here. Again, the likelihood of large solar flares remains nearly 100%. The likelihood of additional coronal mass ejections is 100%. And let's move on to bonus features. We don't want the video to be too lengthy. Satellite charging hazards is the first bonus feature. We've got some minor surface charging hazards here over Mexico and the Eastern Pacific. So that's low energy electrons showing up on the outside of spacecraft. Could cause some minor communications breakdowns, but probably not very much. The GOES electron flux depicted here over the past 3 days. That's the radiographic measurements by the GOES 16 and GOES 18. And remember, folks, we are considering the possibility of a glancing blow CME impact tonight. So if we do see that, you can expect the electron flux to crater. Keep in mind, this is an anomalous measurement during times of geomagnetic storms. Anyway, there is the 1 year graph of the relativistic electrons. That's the 2 million electron volt electron fluence, or 2 mega electron volt electron fluence over the past year from Solon.info. We're just in an operating range at the moment. There's the forecast model, and I would tend to expect this to be much lower. Again, if we do see a CME impact. Otherwise, I would agree with the NOAA forecast. I say that's an accurate forecast, assuming no coronal mass ejection impact. Now we'll look at the layer of the atmosphere where the electron flux is measured. It's the F layer of the ionosphere. It's located at about 300 kilometers of altitude, and there is its vibrational frequency. It's the bridge between Earth and space. So the D layer is at like 100 kilometers of altitude. The F layer is at like 300 kilometers of altitude. Keep in mind it does vary, as it does move up and down based on things like the solar wind activity. When you see a geomagnetic storm, it puffs up. It puffs up kind of like a balloon. It also puffs up a little bit at noontime and so on. Keep in mind there is a lot of heating happening. Radiative heating up there. Anyway, we do see a lot of anomalies here, so let's bring up the latest image and show the anomalygram. So there's the anomalygram. That's anomaly in megahertz from a 30-day median. You're seeing mostly red here, mostly low frequency anomalies. Again, it is geomagnetically calm conditions here, so these are not significant particularly. We show it daily, though, because you never know when you need the data. So anyway, there is 1045 universal time ionogram and 1045 universal time anomalygram. We also show total electron content daily on the channel. It's free electrons to the altitude of your GPS satellites, which are about 12,500 miles of altitude. And here is the total electron content. We are seeing nighttime electron flux electron content anomalies, and also large anomalies in the southern hemisphere. There you can see anomalies in the Southern Ocean and Antarctica. The Southern Ocean and Antarctica. That's pretty hard to say. And Antarctica. Those are the most likely places to see GPS errors caused by signal refraction, as when your signal must communicate with your handset through a lot of free electrons, the signal is refracted. It can cause GPS errors of thousands and thousands of miles. I've experienced it myself. That bike ride was not really at a 10,500 mile per hour average speed, I can assure you. I did not melt. Anyway, there's the North American total electron content anomaly from the 10-day average. Nothing exciting going on there. Let's close out the space weather section with the latest from SDO intensity and SDO magnetogram. So again, we've got, that's a new sunspot group right there. That's a new sunspot group. That's a new sunspot group. I think we're going to have 4 new named sunspot groups today. There's the full disk rockback. The most magnetically complex sunspot groups are this one, and this one, and this one, and this one, and this one. So, yeah, that's, let's see, that's beta gamma delta class. This is also beta gamma delta class, beta gamma delta class. That one's barely beta gamma delta class. That one's barely beta gamma delta class. That's a plage, actually, interestingly enough. That's mainly just an active region there. Only one small umbra on the northern portion of that. Anyway, there's your full disk rockback. And let's move to meteorology. Once again, I was right. So a few days ago, like 3 days ago or so, we cited that these systems, well, this system, Brett, is going to be weak and a complete dud because of Saharan dust, which is depicted here in the DUX. That's the optical thickness of 550 nanometers. Look at that Saharan dust, completely sequestered by these systems, which tamps them down. Also, there was a high pressure system up here when these first formed. You can still see remnants of that anticyclone right here. That creates wind shear, and those two things are not good for the convective processes required for a strong tropical system. In other words, understanding the physics equals the ability to forecast the weather. So yeah, those are both looking weak. This thing is barely even. I mean, we'll show you a forecast here in a minute, but not so exciting for all of you meteorologist types who are hoping for some strong storms. It's just not working out. Anyway, here is the surface wind scenario for the eastern world. Strong low here, south of Australia. Here's the jet stream scenario for the east, and a concentrated jet stream for the southern hemisphere. Here are the jet streams of the west. A jet stream divergence happening in the U.S. there around Lake Superior. Here are the surface winds for the Americas. Surface winds for Europe, Africa, and the Middle East. And the jet streams. Continuing right along, now we're showing dust mass. And once again, check out the dust mass from the windy.com map. That's a lot of dust, and dust does not aid in convection. As you can see, those systems looking pretty weak. So here's the forecast. This is a 72-hour GFS forecast, and you can see this tropical system Brett is about to lose its name entirely. It's barely even going to be a low in just a couple of days. This other system, a little bit stronger here, but it's not going to strike these islands. It's going to stay to the north of them. So it's making a little bit of a turn to the northwest there. Facts. Next, clouds and fog over the Americas as we zoom in closer and closer to the lower 48. Oh, check it out, folks. Look, a harp ring. There's a harp ring. Dutch Sintz probably talked about it on his idiotic YouTube channel. You know, where he doesn't understand how weather works? Oh, look. Look, folks. We've got lines of parallel clouds. That means humans are controlling the weather, right? Just kidding. That's an absolutely idiotic idea. And there you can see those two tropical lows, one of which is breaking up into tiny bits as we produce the video. And there is clouds and fog over North America. Next, our weather.gov map. A lot of weather warnings here, including flooding, excessive heat, And I think those are air quality alerts there over much of Wisconsin, parts of Indiana and Illinois as well. Yep, air quality alerts there. Canadian smoke. If your location is lit, head to weather.gov and click your location. Here come some forecasts for the lower 48. This is your temperature anomaly forecast, since we've got significant temperature forecasts in the form of excessive heat especially. That's your 72-hour GFS temperature anomaly forecast in degrees Celsius. We've also put together an animation depicting pressure and precipitation. Heavy rains there going to form over the Dakotas and Wyoming and Montana and move up into the Great Lakes region. That's a 72-hour GFS pressure and precipitation forecast. And since there's some flooding on the map also, let's do the GFS 72-hour total accumulated precipitation in inches. Some heavy rains there coming to Montana, Wyoming, the Dakotas, Nebraska, Minnesota. Also, Texas and Oklahoma will have some concentrated spots, as well as Florida, southern Florida there, to receive over 4 inches of rain in some tight areas. Again, that's your 72-hour GFS total accumulated precipitation forecast in inches. Next, your lightning mapper. That's what's been going on the past about 10 hours. And here's your real-time lightning map. We've got quite a bit of lightning here around the Gulf Coast, where it's been, shall we say, common in the past month or two. We've got some south of Lake Charles, and we've got some south of Mobile. 2 little storms there. Florida seeing some terrestrial strikes. And I know some people around that area. Hey, some heavy thunderstorms there striking Florida. There's thunder rolling in Sanford Airport. Also Oviedo, Florida. Most of that is to your north. Let's see if we can give you an idea of where it'll be moving. First, if you haven't checked out our links, why not check out our links? You want to see additional content from the channel? Become a member of the Smash Team. There's a bronze level, by the way, which costs you nothing per month. If you are willing to open your cobweb-encrusted wallet, join at the silver level. That's $2.99 a month, or better yet, the gold level. That's $9.99 a month, or the best value of all is the gold annual paid-up subscription. That's almost like getting 4 months free because it includes complimentary merch. SmashOnMash.com/SmashTeam. And you can find links on the homepage. And welcome to the Neo Renaissance. Visit our links. Visit us on social media. Tell your friends and foes. Press share, as the videos are generally not recommended. Why? Because facts. Facts are very controversial. It is the year 2023. After all, of course, information was going down the crapper all the way back as early as about 2011. Certainly by 2012, information was circling the drain. By about 2016, you've been transported to a full-fledged banana republic. Anyway, here is the situation for the full 50 states of AUSA, the allegedly United States of America. And here are the lower 48. Let's briefly show this system here. It is moving east-northeast. So there are some heavy bands there. So some hot water in the Gulf likely there, exacerbating that situation. A lot of convection, and there is more storms to be following it. So that is not going to end anytime soon. Here is the clouds and fog view for the lower 48. And here's the water vapor map. Again, you can see a lot of convection happening there. And you can see there's this impulse all the way from Canada, which is kind of curling around and pushing things to the east-northeast. Anyway, that's the scenario, and here's your recap. That's U.S. Doppler. It shows vertical motion from ground-based Doppler radar systems. This shows 3.9 micrometer infrared radiation from space-based system, the NASA GOES Interactive Weather Satellite. And then there's water vapor. Huge pressure gradients forming over the Oklahoma Panhandle. Anyway, hopefully you understand physics well enough to understand how to forecast your weather. Hopefully you enjoyed the content. Thanks for tuning in to the Smash News Network, Least Busted Name in News. I'm very spooked of space, so I'm headed back to the bunker before all the spooky, scary spaceness hits the spook fan. Bye! Bombs away. Whoa!